All right, thanks for coming back. So continuing off of CSV files, I have a data set here, which is just a regular document, and it is in a comma separated file format. And what you can see is I just have a variety of values separated by a comma, value, comma, value, comma, value, comma. And if I decide to go ahead and open this using something else, like Excel, what I can do is pull it open for week 5. And if I just double click on this file, what you'll see is that I have my computer set so that Excel will automatically open these files, and it uploads it or opens it just like you would see a regular Excel document. So this is the underlying text of that document, and then Excel reads it and puts it into this format. This data sheet doesn't actually have any headers, which is what you're seeing here, which isn't a problem, but this is just to illustrate how a CSV file is just simply a text file with different values separated by commas. Okay, so now getting back to the assignment I had left you on, or the task that you were looking at to try and solve. Let's bring this back up to the top. So now the question is how would you read different sheets of this document? So first, make sure you download this document and have it inside of your working directory, so which I have it right here. And if I wanted to go ahead and open up this Excel, and I inspect it, I'll see that it has 3 different sheets here, 1, 2, 3, and 4. So if I wanted to upload or read specific sheets, then I would just need to use the names for each of these sheets. And what I want you to do is try to pull in the data for the sheet wrong choices and make it into a data set that would allow you to analyze the data in a more approachable way. So for example, you can see that this column is not labeled, and there's a lot of missing values of what animal is what here. You also don't have a header here, no header here. These are okay, but how would you then change this into, or read this in, and then convert it into a format that would be easy to read? So we'll go ahead and work through that as an example. So hopefully you already did the question mark for read Excel or read the textbook. And let's say we're going to read the wrong choices. So I can say wrong choice is the read Excel of my folder, which is in my working directory. So I can go ahead and, oops, ask, go away, what my working directory currently is. So here is my working directory. And then I can specify with the parameter sheet, what sheet that I want to load. Again, if I say I want to run the wrong choices sheet, I get a little error here. So this error, if I read this, it seems to be indicating that I probably actually just have the document still open, which in fact I do. So I need R cannot read a document if you also have it open at the same time. So I just close that document and run it now, and now it runs. And it gives me this new names. And the reason for the new names is it's letting me know that when I read in that data set, it was missing some column names. So it went ahead and just created some for me. If you read the chapter or chapter 20, it will indicate some ways that you can address this at the reading step. Like for example, you could specify the call names at the reading step. In this case, I will not, and I will actually do it after the fact. But we can see that it went ahead and added in .1 and .2 as the column names because I do not have appropriate column names there, which we saw from the original Excel sheet. So I might just call names on my wrong choice data set and figure out, all right, so I created this as a column name and that as a column name. And then these are the column names that it basically just read in. So obviously I want to fix that so I can specify what I want my column names to be. Remember we talked about last week how we can use janitor to produce clean names, which is great. But in this case, it's not clear what those clean names should be if two columns have absolutely no names. So if they had some names already, then we could use clean names. But since they don't, then we'll need to come up with another way to address that. And you can always have addressed the underlying Excel sheet as well by changing the Excel sheet, creating the column names, maybe doing various summaries in Excel, and then reading them into R. The only benefit of doing everything through R is that you have all of the original code. So it produces a transcript, if you will, of all of the different analyses and how you got to them in a straightforward way. If you've ever done an analysis with another program and then gone back a couple of weeks later and tried to produce the same analysis, but now you notice that all the numbers are slightly different, why in the world would all of the numbers be slightly different this time in comparison to last time? And the answer is that a lot of times when you run things, you don't have a record of exactly how everything was run. So this helps by producing a record of how you manipulate the data and in which ways. Okay, so let's say I want to change the column names. I call the function call names on my data set, and then I specify a list or concatenated list of all of the various column names that I want to appear. So if I run this, and I pull up wrong choice, I now have clear column names. But I also have these unfortunate NA values. I also have this total value that I don't want because I want to be able to total the numbers myself rather than using a total column. So I'm going to go ahead and try and fix some of those up. So maybe, for example, I'll take my wrong choice data set, pass it to the command filter, and then say that level shouldn't equal total, and I shouldn't have an NA value for my level. If I do, that probably flags a problem. So if I do that and I come back to wrong choice, I'll see that I have removed my final level, or sorry, my total level. And then also I have addressed the NA row issue where some of the values were just simply NA. As you can see, my other column for species still doesn't seem right. So I want to fix that next. And I notice that the data set is actually decently organized from the prior work, where the column provides essentially the first column is providing the identification information for all of the participants, whether they are a wolf, a short-nosed breed, a long-nosed breed, or some type of hunting breed, I believe, or non-scent, scent, non-scent, wolf, and short-nosed breeds. So what I want to do now is try to create or update the species column so that it would appropriately fill in the species for each of my rows. So one of the things that you want to do is when you're looking at the data sets is first see, is there a specific pattern that I can leverage to make my code essentially repeat that pattern over and over again. And hopefully one of the things that you see is that yes, there is in fact a pattern where basically you get 5 of one species, followed by another 5 rows for the next, followed by another 5 rows for the next, followed by another 5 rows for the last one. So all we necessarily need to do is be able to repeat, say short-nosed for short-nosed here, short-nosed here, short-nosed here, short-nosed here, short-nosed here, non-cent here, non-cent here, non-cent here, non-cent here, non-cent here, then cent, 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 etc. So how do I do that? Well, if we go back to our first week, remember the command rep, which basically means repeat. So I can just say, I want my species column, so go inside of my wrong choice data and essentially overwrite in this case, or create a column called species if it's not already there, and repeat the word wolf. So repeat the value wolf or word wolf 5 times. Then repeat the word cent 5 times, then repeat the word non-cent 5 times, and then repeat short-nosed 5 times. And then if I run this, oops, sorry, I ran that one. My wrong choice now gives me the species for each of these columns in a compressible as well as a easy to manipulate manner where it wasn't before. Now, similar to kind of like the exam data set, maybe I want to explore some of this. And I see that like the number of false choices an animal makes, the number of no choices, the number of attempts. I want to put this all on one singular graph so that I can look at the relationship between species for false choices, no choices, and no attempts in a relatively easy way. To do that for ggplot, what I need is all of these to be in one column. So I have a column that indicates my variable type, false choice, no attempts, and another column that gives my actual value. And if you remember for last week, the way to do that would be to do a pivot, or specifically a pivot longer. So I'm going to create a new data frame called wrong choice W, referring to a wide or going from wide to long format. You can make this anything you want. So let's say I can make this L because it's actually the long format. So wrong choice long format is going to be my wrong choice data set. I'm going to pivot it longer. And if you remember from last week, there are a variety of ways that I can indicate the columns that I want it to use to convert to the long format. I'm here using what would be the most straightforward. I could use the column names directly, or I could use other means to specify the columns. But I'm just going to say I want columns 3 through 5. So if this is 1, this is 2, this is 3, 4, and 5. I want to collapse columns 3, 4, and 5 into a new data set that otherwise has the same data, but then repeats the value of level and for each wolf to produce a singular column of whether it's a false choice, no attempt with the related value. So if I run this and I specify that I want a new column called errors for my names or for my different types of mistakes, and then my values too will become number. I get a new data set in the long format, so it increases the number of observations here, where I still have wolf, the level, and then now the error is going to be false choice, no attempt for each individual animal and species. So for wolf 2, I had 12 false alerts and 0 choice, no choices, and 0 no attempts. Whereas in contrast, wolf 2 also did a relatively similar thing. And then we also have wolf 3, 4, etc. all set up for us now. And then finally, once we have that, we can actually make a graph. And we can specify our graph to create different plots for each of the different error types. And now I'm not saying that this is exactly the way that it should be analyzed, but this is a way that you can actually create a graph and look and see, are we on the right page? Are we making progress in understanding what data that we have? Or perhaps maybe I have issues related to um, the uploading of the data or one of the other tasks that we have done. So what I'm going to do is create my plot. So I'd say ggplot. My data comes from wrong choice. This now actually needs to be an L for long. Then I specify my aesthetic, where my X is the level. So whether it was level 1, 2, 3, or 4. My Y is the number. So the number value that used to be in the wide format. And then I'm going to say color is equal to species, and that group is equal to species. So what this does is that this says color, so make a different color for each species. And the group command says, I know that my X variable, level, is not a numeric variable. When what I mean by that is it's level 1, 2, 3, 4, 5. That is a factor variable. It's not reading it as literally the numbers 1, 2, 3, 4, 5. So because of that, that means that we need to um, sort of add a additional specification so that R will draw the line between my various points. Because if I just leave it as is, those points would become data points, but then I wouldn't see other kinds of, uh, I guess, if you will, other kinds of measures or metrics in there. So by creating group equal to species, what I'm able to do is create a line across my level factor. So because level is a factor variable, it inherently does not draw a line from level 1 to level 2 to level 3 to level 4 to level 5. And the reason for that is because it reads it as a factor. Level 2 could be higher or lower than level 3. It doesn't actually know. So I have different options. One is that I could use the parse number function that we had before. So say, for example, I can create wrong choice L. Level 2 would be parse number wrong choice level. Then I now have a level 2, which is the parsed number over here. And then if you didn't like this way of doing it, I could also use the dplyr method. Would be just create a space here. Yeah. And then I will pipe this data over to my mutate function, which will create a new column. We'll call it level 3 is equal to parse number. So this will create a third column, level 3, in the exact same way. So there's no difference between this line, and this line in function. The only difference is how I get there. Both are correct. There's no bonus points for one way or the other. The second way is slightly more in tune with the methodology of the textbook that we're following, but both would work equally well. Okay, so now what does this all mean? So from our ggplot, if I take this and say, for example, I don't have a grouping variable, then what I get as a plot are my various points, but I do not get a line drawn from one point to the next. If I wanted a line, that's why I would need to specify my group in this second one here. And what the grouping variable is saying is for the line argument, or my adding of a line, I want a line per group variable, and that group is species. So I want you to draw a connected line across species. R didn't do it by default in the previous case, because each x value is a factor variable. So it doesn't know or doesn't think that there necessarily should be a line across here because that 1 goes to 2, that goes to 3, that goes to 4, that goes to 5. But otherwise, if I would have taken this exact same code, but instead of using my level, which is a factor variable, I use my level 2, which was the result of the parse number, I wouldn't actually need that grouping variable. It would just draw the line for me automatically because I specified draw line or GM line here. So that grouping variable is saying that, yes, I know that you recognize that my x-axis is a factor variable and you shouldn't draw a line there. I want you to draw a line anyway because I know better, and that line should be one line per species. The other approach is that you could say, oh, well, it's recognizing that it shouldn't draw a line because my x-axis is a categorical value, level 1, level 2, level 3. Maybe I should change my x-axis to a numeric variable, and then it would be happy to draw that line, which is what it does here. So that gives us an intro to uploading some different data types, as well as taking in or loading in a specific sheet from an Excel file, and then modifying a poorly designed Excel sheet into something that we can crunch numbers. Then we turn that sheet into a long format that allowed us to do plots. And then from that plots, we figured out issues related to drawing a line when our x is a categorical variable, and then solve that with parse number or by specifying our group value to species. All right, hopefully that gives a quick little summary of that. We will come back with more plotting information in the next video.